now we're going to cover potential energy. This is going to be a tutorial, and we're going to do one example, which is going to be split in 3 different examples, okay? So we can understand this and go through this step by step, okay? So first of all, what is potential energy? Okay, potential energy is the energy an object has due to its position or state, okay? So it doesn't really say much, does it? But I have to say that the potential energy is measured in joules, okay? X is going to be the number, so it's going to be measured in joules, okay? That's the measurement we're going to measure it, okay? So, next of all, gravitational potential energy. This is the thing we're going to be covering today. So, it is the energy of an object due to its position above the surface of the Earth, which means is so this is the formula we're going to use. P potential energy is equal to mgh, which is mass by the gravity by the perpendicular height. Okay, so I'll understand it. Okay, I'll explain it now. So let's say we have a suitcase with a mass of 1 kilogram is placed on the top of a 2 meter high table. By lifting the suitcase against the force of gravity, we give the suitcase a potential energy. The potential energy can be calculated using the equation. What equation? This one here. Okay. So let's keep going. Let me just explain, okay? So if the suitcase falls off the table, it will lose all its potential energy. Halfway down the table, the suitcase will have lost half of its potential energy, and we only have half of the potential energy, okay? So at the bottom of the table, when it's on the ground, the suitcase will have lost all its potential energy, and all its potential energy will be equal to 0. So what I mean is, so if this is the suitcase and this is the table, okay, this is the table and this is the suitcase, okay, the suitcase is on top of it, okay. So just by being on top of the of 2 meters above the ground, the potential energy is going to be if we apply the equation, it's going to be 19.6 joules, okay. So it's going to have its maximum potential energy because it's 2 meters above the ground. But when the suitcase is halfway through here, let's say just here, halfway through, so it's going to be 1 meter above, it would have half of its maximum potential energy, which would be 19.6 divided by 2. Okay, so that would have been if it's like halfway through. But what if the suitcase is just on the ground right now, and it's just on the ground right now? Well, the potential energy, it's at a minimum. Why is it? Okay, so because the height, the perpendicular height is equal to 0, this is equal to 0. Well, anything multiplied by 0, because this is 0 and this is all multiplied, well, anything multiplied by 0 is 0. So you can see the potential energy is going to be 0 joules, okay? So now that we have that covered, let's do an exercise and see if we can do it, okay? So we have a boy of a mass 30 kilos climbs onto the roof on their garage. The roof is 2.5 meters from the ground. He now jumps off the roof and lands on the ground. How much potential energy has the boy gained by climbing on the roof, okay? So let's do that part first, okay? Part A, how much potential energy has the boy gained by climbing the roof? Okay, so we know the boy has a mass of 30 kilos, okay? Then we also know that the height of the roof, because when he's just finished climbing up the roof, his height is going to be 2.5 meters above the ground, okay? And then we also know that the gravity is 9.8 meters per second square. So we're going to use our formula. Potential energy is equal to mass by gravity by height. So the potential energy measured in joules, remember that, is going to be 30 multiplied by 9.8 multiplied by 2.5, and this is going to give us our result of, let me just get the calculator here for a second. So it's going to be 30 by 9.8 by 2.5. So it's going to be 735 joules, okay? So what it means is that when the boy just climbed up to the roof, its potential energy is going to be 735 joules. Why is that? Okay, because he's on a height and his mass is 30 kilos, then that's his potential energy. It doesn't matter if he's just like standing on the room not moving, he already has the potential energy. Okay, so that's gonna be our result. Let's do part B. The boy now jumps down. What is the potential energy of the boy when he's 1 meter from the ground? Okay, so if the boy is here, this is the roof. Okay, and this is the boy here being really happy, and it's about to jump. Okay, so this is 2.5 meters. This is the ground. Okay, 2.5 meters. So the question is asking us, what is potential energy when the boy is 1 meter from the ground? So when the boy is around here, which is 1 meter, so when the boy is just here, what's potential energy? And this is the ground, so it hasn't reached the ground yet. So basically, its height at this moment is going to be 1 meter. So instead of using 2.5 meters, we're going to use height as 1 meter. So we have that the mass is equal to 30 kilograms, that the height is equal to 1 meter, and the gravity, as always, is going to be 9.8 meters per second square. So now we use our formula that we really like. So it's going to be mgh. Now we know that potential energy is equal to the mass, which is 30, by gravity 9.8 by 1. Okay, so now we get the calculator again, and we know that the potential energy when it's 1 meter above the ground, okay, 1 meter, is going to be 30 by 9.8 is going to be 2 point, no, it's not going to be 2 points, it's going to be 294 joules, okay? Always remember to put the units, okay? Because you might get marks off in your exams, okay? So let's do part C. What is the potential energy of the boy when he lands on the ground, okay? So basically, as we said here, I'm gonna copy this diagram here so I can explain again. Copy. Let's say when the boy is actually on the ground, he just landed and he might have like breaking a few legs, like a leg or something, because it's a bit high. So when he's just on the ground, the height is gonna be equal to 0, because its height is relative depending on the ground. So when he's on the ground, his height is going to be equal to 0. So we know that the mass is equal to 30 kilograms, that the height is equal to 0, and the gravity is equal to 9.8 meters per second square, as always. So we have that the potential energy is equal to mgh. So we know that the potential energy is equal to 30 by 9.8 by 0, but anything multiplied by 0 is 0, isn't it? So 30 by 9.8 is 294, but multiplied by 0 is 0, so its potential energy is going to be 0 joules, as we said at the start of the tutorial, okay? So I hope you like this video. It has a tutorial and 3 different examples we can do, and you might get different ones, but always remember to read the question really carefully and write the data you know about it, okay? And if you draw a diagram after this, it might be easier for you to visualize it, okay? I'm going to upload this onto Dropbox, and I will put the link on the description so you can download it and look at it and save it into your notes if you want, okay? So thank you for watching.